There are two different things you could be asked to find when finding the rate of reaction from a graph. The first one is the average rate. If I want to find the average rate, I need 2 points. So suppose I want to find the average rate between 0 and 60 seconds. So what I would do is I would find a time of 0 and a time of 60 on the graph, and then I want to find the data point associated with each one of them, which I can read off the graph. So this first one would be 0, 1.2. And the second one would be 60, that looks like about 0.6. If the average rate is going to be the slope of this graph, because that will give me the change in concentration over the change in time, which is also going to be equal to the change in y over the change in x, or the slope between these 2 points. So my change in y is negative 0.6, being the difference between that and that. And the change in time is 60 seconds. Dividing 0.6 by 60 will give me 0.01. It's technically negative 0.01, but we ignore the negative sign. It's sort of, we tend to express the rate of a reaction as a positive value instead of a negative value. But my units are going to be moles per liter, which was the units of concentration, divided by seconds. Or you may see it as moles per decimeter cubed per second, or you may see it as mole dm -3 seconds -1. Any of those units are acceptable. The value here would be 0.01. Additionally, I could ask you to find the instantaneous rate at some point in time. If we want to get the instantaneous rate at some point in time, what we're trying to do is we're trying to find the slope at a particular time. In this case, the time I'd be looking at is 40 seconds. Now, the slope is constantly changing. So the way we find the slope when something is changing is we use a tangent line. I'm going to add in a tangent line. Now, the trick with a tangent line is it's only supposed to touch the curve at one point, and exactly one point. And this one point is going to be at the time of t equals 40. So I'm going to work on adjusting this line until I have it only touching at t equals 40. And a tangent line is not allowed to cross the curve either. Okay, so now I believe I have my tangent line about as good as I can get it. And now what I want to do is I want to find the slope of this line. So to find the slope of this line, what I want to do is I want to find two places where it intersects the grid lines. I can either use the axes, or if I find somewhere else that I think it intersects really nicely, like it seems to intersect here, that point seems to be 120, 0.1. I'm also going to use the data point where I find in the middle of this circle, I have an intersection right on the grid line, which that is happening at 10, 1. So using these two data points, I'm now going to do change in y over change in x, which will give me the change in molar per second, which is indeed the rate of the reaction. So my change in y is going to be 0.1 minus 1. My change in x is going to be 120 minus 10, or negative 0.9 over 110. Again, we can ignore the negative sign, so it'll be 0.9 divided by 110, which gives me 0.008 moles per liter per second.